this, we just had to make a little arrangements to our house inside the music room. But we are going to look at this topic called differentiation. Differentiation is a process of differentiating a function. Now to think about it, rule 1 is that given the function y equals f of x, then it can also be written as dx, it can also be written as limit x approaching 0 of delta x, delta y. Delta x is the change in x, and delta y is the change in y, or delta y over delta x. But it's the same as limit h approaching infinity of f of x plus h plus f of x divided by h. So, easier rules is that c prime equals 0 where c is a constant, and then x to the n prime is n times x to the n minus 1, or if you want to specify it a bit, a times n to the x. So a times x to the n is equal to a times n times x to the n minus 1. Where a is a constant. A has to be a constant for that. Because if that is not true, then there's this thing called the product rule, but we're going to talk about it in just a bit. So, it says that cu prime, all that, is equal to c times u prime. And, we're a constant. So, given that u is f of x and v is g of x, and then u plus v all prime is just basically u prime plus v prime. And then u minus v prime is basically u prime minus v prime. But now the product rule says that given that u and v are functions of x and letting the derivatives of u and v be u prime and v prime respectively, then u times v all prime is u prime times v plus u times v prime. Now, that's why I said that if a is not a constant in the case, then technically that's going to mean that we're just going to have some, we're going to basically be just, not doing the right thing. So, technically, u prime v plus u times v prime is the formula for the product rule. But the quotient rule says that given u and v are functions of x and letting the derivatives of u and v prime and of u and v be u prime and v prime respectively. Anyway, u over v all prime is equal to u prime times v minus u times v prime all over v squared. And then another rule called the nth order derivative is that in general, the function obtained by differentiating the function y equals f of x n times is called the nth order derivative of x and can be written as this. So, for example, for a second order derivative of, the second order derivative of, 3x cubed. To find the first and second order derivative, first use this rule except add the a there. So, 3 times 3 is 9. 9x, 3 minus 1 is 2. So 9x squared is the first order derivative. For the second order derivative, 2 minus 1 is 1, so it will just be x. And then 2 times 9 is 18. So you have 18x. Note that it's not just the value of the... It's not just, the value of the function and, that's all. It's not like you can just multiply 2 by the constant 3. No. You have to multiply it by exactly what the first order derivative is. Like pretending you didn't even differentiate it yet. Pretending it was like that the whole time. But now, remember, the x of n prime equals nx n minus 1 is true when n is a rational number. And in fact, for inverse functions, dy over dx equals 1 over dx dy. Whatever. And then we got, as well, that if a composite for the differentiation formula for composite functions, when u equals f of x and y equals u to the n, y prime equals n times u to the n minus 1 times u prime. All right, so to look at the advanced, let's look at some more just advanced formulas. So we have that sine x prime, the derivative for sine x is cosine x, the derivative for cosine x is negative sine x, and the derivative for tangent x is 1 over cosine squared x. And there's an easy way to find this out. Given that these two functions are true, it's easier if we find these two first so we can find this one. So after we find these two, we just apply the quotient rule, because remember the identity from trigonometry that tangent x is sine x over cosine x? Well, we take sine x over cosine x and replace it with tangent x, and then we take that prime, which we only need to use the quotient rule. And there you go, 1 over cosine squared x. Alright, so also, from the definition of the logarithm a equals e to the log base e of a, therefore, a to the x is equal to e to the x times log e base ea. And a to the x prime is a to the x times log base ea. When a is a positive number, the logarithm of a to the base e is called the natural logarithm, and is usually written as ln a, where ln a is equal to log base e of a. So the rule is that e to the x prime is equal to e to the x, and a to the x prime is equal to a to the x times natural logarithm of a. All right, now to look at even more advanced differentiation formulas, we're going to look at these three other ones. Well, where x equals f of t and y equals g of t, where dx over dt cannot equal 0, dy over dx is dy over dt divided by dx over dt. Now, then, the derivative for a natural logarithm is 1 over x. And then logarithm base a of b is the same as the natural logarithm of b and over the natural logarithm of a. And that's pretty much it for differentiation formulas. And we're in the next part we're going to look at we're going to take a look at these formulas visually, and we're going to work through some examples with this.